Hi everyone. This is the very last example in our 6.5 notes, and again it's just one more example of finding the slope from a graph. This time, this last example, we're looking at a graph where we actually have a quantity on the y-axis, so it's distance in miles, and on the bottom on the x-axis we have time. So we're graphing distance versus time here. Slope is always giving us a rate of change. A straight line has a constant slope. So we're figuring out what is the constant change in y with x. Okay, so slope is equal to the change in y over the change in x, which is just the rise over the run. And if it's a straight line, this is always a constant value. So we're always going to get a number here. And it's telling you that if I move any change in x here, okay, I know what my change in y is going to be. So that will be true for any points on the straight line. So this is always constant whenever there is a straight line. So for all linear relationships, this is true. Whenever our graph is a straight line, we have a constant slope. The graph below here shows distance versus time, and let's go ahead and figure out what our slope is. So again, we could use our method, which is just to pick 2 points, any 2 points that have clear coordinates. And so you could choose any 2 points on this graph where you can see. You might decide to choose the first and the last point, or you might choose the first point and the second point that we see here. Okay, or we could choose to use, if you have the point 0, 0, it's a great point to use because it makes the math easy for you. You're always going to be, subtracting 0 for one of your points here, which is handy. Okay, so we could use the first point and maybe this last point here. So this first point is the point 0, 0, because it's at 0 for my x and 0 for my y. Okay, notice that my graph is going up by 80 on the y-axis. So 80, 160, 240, 320. So it's not going up by 1 mile, it's going up by 80 miles. Okay, over here, this point here is on my, if I come down to my x, I see that I'm at 6, okay, hours. And if I come over to my y, I'm at 240. Okay, so I could use those 2 points, and those would be great points to use. I could use the formula if I wanted to, or I could just count my rise over my run. Okay, if you count your rise over your run, you just have to be careful that when you're counting each one of your divisions on an axis, make sure you know how much it's worth. Okay, so let's count the rise over the run. Let's go from the first point to our second point. So the rise, to get from the first point to the second, I have to go up this many. There's my rise. Well, what is that? I went from 0 all the way to 240. Okay, so it's different here. I don't count 1, 2, 3, because that distance, that rise, is not equal to 3 miles. My divisions here represent 80 miles each. So if I go up 80, then 160, and then 240. So it's 3 times 80, okay, or from 0 to 240. So if I'm using the rise over run method, I'm going to put in positive 240, okay, for my rise, and that's in miles. That's what MI stands for on my y-axis, over the run. Now to get from point 1 to point 2, I have to also go over, let's see how many. Again, come down to your x-axis and look. Each division on my x-axis is worth 2. So I have to go over from 0 to 6. So my run is equal to 6, or you could also count it. This first line here is equal to 2. So 2, and then 4, and then 6. Okay, so my run is 6. 6 hours. That's what I'm given down here. So sorry, I should just use H to be consistent. Okay, so my rise over my run is 240 over 6. And again, I can get this into lowest terms. Okay, 240 as well as 6 are both divisible by 6. Or you could take in your calculator right now and just try 240 divided by 6, okay, into your calculator, and you're going to get 40, okay, as an answer here. So 40 over 1, or just simply 40 is fine. Okay, so 40 miles per hour, okay, per 1 hour. can also be written like this, 40 miles per hour. Okay, what did we just calculate? We figured out the rate of change for our graph. This right here, miles per hour, is equivalent to the change in distance over the change in time, which is speed. This is speed or a velocity. Okay, miles per hour is a way of measuring speed. So it's telling me every hour I'm traveling 40 miles. I'm driving at a constant speed if I'm driving here. Okay. Obviously, I'm not walking 40 miles per hour. That's pretty fast. So the average rate of change here is 40, okay, miles per hour, and that is a constant rate of change. So that is constant speed. Straight line graph that I'm measuring distance versus time on. When I find the slope, it's telling me my speed, and I already know it will be constant because it's a straight line. So finding the slope just tells me the value of the slope. What is the constant speed? It's 40 miles per hour. Good. So this is the last question that we had in our notes. You could have also solved this using the formula. So you could have picked 2 points on this graph and called 1.1 and 1.2 and plugged them into your slope formula. That would have given you the exact same answer, 40 miles per hour. Just remember, no matter which method you use, when you get your slope, if you pick 2 points that are somewhat far apart, you may need to reduce that slope from a fraction to the lowest fraction, the lowest term fraction that you can. Okay, or try dividing the top by the bottom and see if that gives you a nice, okay, a nice whole number. And then there you have your slope. Okay. That's it for now, folks. So go give your 6.5 questions a try. Good luck, and thanks for joining me. Bye for now.